This session is basically entitled Developing Apps for the Universal Windows Platform. And really, as I mentioned, what I want to do is just make sure you all have an understanding of what the Universal Windows Platform is all about, and some of the reasons why you might want to consider making the same decision that Turnkey did 12 months ago, or a little bit longer than that, and decide to develop for that platform. So this presentation will give you an overview of what the platform is, a little bit of primer information about how you go about developing apps for the UWP environment, how those apps are then deployed, and just some miscellaneous information. So what is a UWP application? Well, it's an application that's built and runs on top of the Universal Windows Platform. The Universal Windows Platform is something that was first introduced in Windows 8 and subsequently 8.1 and 10, and back then it was referred to as the Windows Runtime, or WinRT. And it was this whole new environment that was built into Windows that was available, and back then we used to think of them as store apps. Okay, that whole concept of, we all remember that lovely Windows 8 start screen with its big tiles and those touchy-feely apps that that really were kind of strange back then. Well, that whole thing has grown and matured into what's now called the Universal Windows Platform, and it's about an awful lot more things now. The whole platform was built on the core principles that users, in an ideal world, like their experiences to be mobile across all the platforms and all the devices that they use and they encounter during the day. So they'd like to be able to maybe work on something on a desktop PC and continue it on a tablet or a cell phone when they're traveling, and then maybe on a different PC when they get back home, or a tablet sat on the couch while they're watching TV, and they'd like that application to be portable and seamlessly integrate along with its data across all of those platforms. So that's one of the core sort of design tenets of the whole platform, that users want to be able to do whatever it is they do on any device that they choose to do it. And Windows 10 finally makes it an awful lot easier than it used to be. The old WinRT environment had a lot of restrictions. There were a lot of things you couldn't do, and it was pretty hard to develop applications for. Windows 10 has solved an awful lot of those things and made it an awful lot easier to really build applications in this environment. UWP is not just about Windows desktops and laptops. It's about a whole range of devices, some of which are available for use today, some of which are currently in what's called developer preview. But as you can see from this slide, it is about quite a large range of devices, from, of course, desktop PCs and laptops, including tablets, cell phones, ruggedized devices. Windows 10 starting to crop up on quite a wide range of rugged PCs and other kinds of devices now, including newer members of the family like the big Surface Hubs, the 84-inch wall-mounted environments that run Windows 10 for team collaboration and that kind of thing, across devices like, for example, the Raspberry Pi, Internet of Things type devices. We're starting to see Internet of Things become a reality in more and more devices. You've probably all seen the commercial for the $5,500 Samsung refrigerator with essentially a portrait mode tablet built into the door and a whole bunch of sensors and cameras and all that kind of stuff. I'm not saying that's running Windows 10, I'm not sure what it runs, to be honest, but that kind of class of device is what we're referring to with the Internet of Things. And also other devices like game consoles. Right now the Xbox One is in developer preview. It's a Windows 10 device, as is the HoloLens that some of you will have seen me presenting a little bit of information about last year. So there's a whole range of devices, and those devices all have differences. They have different screen sizes, different aspect ratios. Some of them don't have screens. They all have different types of sensors and so on, but they all have a lot of commonality as well. And in fact, one of the areas of commonality is they all run Windows 10. Okay, so there's an awful lot of base features that if you write to that set of base features, potentially you can create an application that will run across all of those, or a subset of those, or you can, of course, target one specific type of device if you wish. But it is possible to write a single application. And I'm not just talking about single source code, I'm talking about a single binary that can be deployed to a cell phone, a tablet, a PC, and a HoloLens, for example, or any combination of those devices. They all have different characteristics. Screen size is obviously one of the biggest differences. So phones and phablets being typically 4 to 5 inches, tablets sort of taking over above that. A lot of us, it's easy to think that a mobile app is a phone, a phablet, or a tablet, but actually a tablet is more similar to a PC in many ways these days. Certainly with its screen size and the aspect ratio, they tend to be used in landscape quite a lot. So all of these devices have their own sort of set of capabilities and their own unique things. That, like I said, you can write specifically to a certain type of family, you can write generically to the core set of APIs, or you can write to specific devices. PCs and laptops, obviously, typically we're looking at, again, usually landscape mode, but not always, and typically, 12, 13-inch plus type screens, and then it goes up to the giant screens. Right now there are 2 Surface Hubs available, 55 inches and 84 inches. And clearly, how do you design the UI for an application if you want it to run from something that might be that big to something that might be, 10 feet across? They talk about the 10-foot experience when you're talking about the Xbox, for example. You're sitting typically 10 feet away from it, and it's a 60, 70, 80-inch device at that point. What impact does that have on the user interface? Okay, and these are some of the things that we'll explore in a little bit of detail in this session. And then down to a completely different class of devices. Again, the Internet of Things. This is an image of a Raspberry Pi, and that is yet another device that can run Windows 10. Okay. Typically there's no user interface involved in this. Typically it might be running some application, typically running the same application all the time, connected to some physical hardware sensors, monitoring something, monitoring temperature, pressure, whatever it is, light, whatever it happens to be. But these kind of embedded devices in everyday consumer products and in industrial processes and so on are becoming more and more common. And we have ways of writing applications to be involved in those kind of functions. And then there's the whole new classes of devices that you might think, well, this will never impact me. And maybe you're right. Maybe Xbox and Xbox running on a TV. I struggle to see a commercial use for that. It largely is about gaming and entertainment, but maybe some of us are in that marketplace. But devices like the HoloLens, while initially it was kind of a bit of fun to think about this use of holographic imagery in applications, when you actually start to think about it, there are all kinds of potential applications in science and in industry and in education and in business even. We've seen some great examples already of modeling, 3D modeling of new buildings and that kind of thing. Some of the videos I showed last year were educational applications in the medical field, holograms of the internal workings of the human body and things like that. What surprised me is how much interest there now is in the commercial and industrial space. Only 3 or 4 weeks ago, myself and Bill and Nigel toured several customers. We visited some of you in the Northeast for a week. And I think the subject came up on at least 2 occasions, and we weren't the one bringing up the subject. It was like, oh yeah, thinking of getting a HoloLens to do picking systems in the warehouse so we could just direct the person walking around the building. They're not following lights anymore. They're now interacting with this thing that is overlaid over their real vision and stuff like that. Go here, big red arrow, get 4, okay, done that. That kind of application, I think we're going to see an awful lot more of. Of course, we're all just looking for an excuse to order a HoloLens as well. When it comes to the universal, so there's all these different kinds of devices you could attack, and yeah, I think I don't really see a big commercial use for putting our kind of apps on Xboxes and stuff like that. But certainly phones, tablets, desktop devices, laptops, and I can see maybe the IoT thing and HoloLens becoming more common than they are today, certainly. The way that the Universal Windows platform works, actually, I think is quite clever. You don't target specific devices. What's happened is the APIs have all been grouped together into device families. So you target device families and any current or future devices that then subscribe to that family, your application will work on. And you can target one family, you can target any number, a subset of all of the families, or you can target the whole range and decide where your application is going to run. And obviously by picking the families, that determines what APIs are available to you, what you can do, what you can't do, what you would have to do with if-def code, so you can detect, oh yes, I'm on an Xbox device now, so I can expect there to be a game controller available, that kind of thing. So you don't choose and target specific devices. you choose the mobile family or the desktop family or the IoT family, and that determines the capabilities that you have available to you. It also determines the devices that your application can be installed onto. Another thing that you need to really think about when you even consider UWP is input, because there's an awful lot of different input mechanisms now. And in my mind, this is actually one of the reasons that people may be tempted to go with UWP over another technology like WPF, for example. Even if you choose to do universal Windows, but only target desktop and laptop class devices, there are some really good reasons to do that. And one of them is that the set of controls that you build UWP applications with basically inherently support all of these different kinds of inputs. So they do keyboard and they do them all pretty well. So they do keyboard and mouse input, they do pen input, they do touch input, pen and ink. They support game controllers and all that kind of thing. WPF is great for a desktop keyboard and mouse kind of scenario and has some touch capabilities, but it's not a great experience with touch, where UWP is going to give you that touch experience. And more laptops and even desktop monitors these days are touch enabled. So to me, that's probably one of the biggest driving factors for making the choice for this platform. Language choices for UWP. You can write UWP apps in a wide range of languages. You can write them in managed code using C# or VB. We do have some experimental support that's been there since Synergy 10.3.1. It is a little basic, and obviously Roger this morning mentioned that in v.next, the next planned release of Synergy, we'll have comprehensive support for the Universal Windows platform. The UI, if you're working with a managed language, the UI is fairly familiar to a lot of us these days because it is built with XAML. It's not the exact same XAML that WPF uses, but it's very, very similar. So if you've ever done any WPF, you'll be pretty comfortable with UWP user interface work fairly quickly. And that's the way that most apps are developed. Most UWP apps are developed using a managed language, C# or VB, and with XAML for the user interface. You can write UWP apps with unmanaged code with C++, for example. Normally in that world, you would implement the UI possibly with DirectX, or possibly with XAML still, but the time people tend to write in C++ and DirectX is for high-performance gaming environments, and that applications that require highly graphical custom UIs, not sort of form and field and control-based type UIs. And it is also possible to write UWP apps in a combination of JavaScript and HTML and CSS. And that was done to really make it easy for web developers to get in and play in this world. So you can write Universal Windows apps using those traditional web type tools and technologies as well. UWP apps run on top of what's called the Windows runtime, and that's a native set of APIs that are built into Windows now, have been since Windows 8, and they've, like I say, matured and been extended an awful lot since those early days. And they are supported in a way with an API that feels natural in those languages. So the APIs are somewhat different if you're working in the HTML and JavaScript world, and it feels totally native to the JavaScript developer, for example. There are also templates to get you started in Visual Studio. There is a blank application template that just gives you a very basic shell in which you create things, and there's a class library template as well. And there's a whole bunch of sample code and sample applications that are all available online. Most of them are in Microsoft's GitHub repositories now. That's where they tend to put all of their examples and open source type stuff. So UWP APIs, as I already mentioned, there are a set of core APIs. The core APIs do the majority of the work in most apps, and the fact about the core APIs is, as the name suggests, they are core to all of the platforms. So the idea is if you write the core APIs, you can assume they will be there on any supported platform, and you can use them freely. And then there are extension APIs. Clearly, if you think about the broad range of devices that UWP supports, Desktop PCs have a certain set of characteristics. Devices like a HoloLens or a mobile phone, for example, have a whole different set of characteristics. Some of them have certain types of sensors, some have cameras, some don't, some have accelerometers and pressure sensors and all of those kind of things. So that's where these extension APIs basically come in. If you're coding some of the, by selecting a certain type of family, that might give you access to a certain type of sensor, or you can also write conditional code that says, is this API present? And if it is, therefore I'll go ahead and use it and write conditional code that way as well. Windows 10 also provides various types of things that are there to support UWP applications. Things like you would expect, things like live tile support. Obviously live tiles is a fairly big thing in the Windows world these days. The action center where actions can be exposed and messages can be exposed. There are now mechanisms, fairly extensive mechanisms to do background execution of tasks and things like that. Actually there's a lot of new features in that area coming in the Windows Anniversary Edition in the summer when it gets released as well. There are specific APIs or services that Windows provides to allow things like voice integration to happen. And Windows actually has quite an extensive set of APIs now to help you do things like roaming data. So, making it really easy to have an application, work on an application on a desktop PC and then roam that data out via the cloud and open the app on a tablet, for example, and hey presto, that data's been roamed over to that device. Obviously, it's all under your control as an application developer, and things like that require the user to opt in as well. It's fairly common now when you first open an application, it says, we need access to your camera, we need access to this, we need to be able to roam data. So all of these things are subject to user permissions. Also, Windows now provides something called the Windows Credential Locker, which again is a way of roaming securely credential information about who the user is around between these different kinds of devices, if the user allows you to do so. Let's talk a little bit about designing UWP apps, because it's quite different in some ways. Designing an application for a desktop PC is one thing where you can pretty much expect to have a screen that's going to be sort of this big, somewhere in that range. But how do you go about designing an app if the screen might be that big? But also it's got to run on a screen that's that big and this big and that big as well and still look good and work well. And the UWP platform provides a whole bunch of things that make that possible and make it easier to deal with. So, your application has the potential to run on all of these different devices with different screen sizes, different aspect ratios, and so on. And how do you go about doing that? Well, one of the biggest things is this thing that it has called effective pixels and scaling. So basically what happens is that the platform itself takes care of scaling and sizing controls and fonts and grids and images, anything that's part of the UI, basically automatically get adjusted based on the criteria or based on the characteristics of the particular device that it's running at that point in time. And that whole system is called effective pixels. And the result of that is, as you can see on the diagram there, the idea is that as a developer, you say, you just work in basically relative sizes. So something that's 24 point, it's still called 24 point, but it's not necessarily a fixed point size in terms of the number of pixels, is going to appear the same on a little tiny screen as it is on a big screen. And that diagram tries to sort of highlight how that works. Rather than me try and explain it, because I'm not a developer, let's just watch a brief piece of video that helps you understand how that
Universal
works.
Windows platform apps automatically scale your UI to ensure the UI elements display properly when your app runs on any device, regardless of the pixel density or the viewing distance of the device. Let's take a look at how this affects the UI elements you design. Because an app scales your design elements for the device it's currently running on, when you design elements in pixels, you're actually designing in effective pixels. Here we have a UI element that is 100 by 100 effective pixels, some text with a size of 100 effective pixels, and some text with a size of 24 effective pixels. Here's how these UI elements render on a PC, a tablet, and a phone. When the screens are compared side by side, elements on the PC and tablet seem larger than the elements on the phone. The 100 by 100 UI element displays in 150 by 150 physical pixels on the phone, 175 by 175 physical pixels on the tablet, and 200 by 200 physical pixels on the PC. These devices have different screen sizes, viewing distances, and pixel density, but when you take into account the viewing distance for each device, the elements all have the same perceived size. This enables you to use the same element and font for all devices. And that, in a nutshell, is how display scaling and effective pixels frees designers and developers from having to consider pixel density and viewer distance.
Okay, so that maybe gives you an idea of the way that the platform tries to help you. You know, it's not that you have to sit there for hours designing all of these different UI experiences for a tiny screen, a medium screen, a big screen. And so there can be a certain element of that, but a lot of the basics can be taken care of for you. So you're designing as a designer building a user interface based in these effective pixels, and that really allows you to pretty much ignore a lot of the really complex lower level stuff. One thing that is important to know is that when the platform does scale the user interface, it scales it on a grid of 4x4 effective pixels. So typically when you design your things, one of the things you do want to do is make sure you design things in multiples of 4 pixels. So, you know, don't size something at 13 because it's going to be fuzzy, because it's going to get stretched to, it's going to get stretched to either 12 or 16, basically. But other than that one basic rule of do things in multiples of 4, the platform really kind of helps you out an awful lot. And, the whole platform, like I say, works with device families and size classes. So you don't tend to design an application to work for a phone versus a tablet versus a 10-foot screen on an Xbox or whatever. What you tend to deal with is small, medium, and large sizes, and let the platform do things for you within the realms of those things. So small is considered 4 to 6 inches. Typically, it's pretty much cell phones and so on. Medium is the 7 to 12-inch range, and TVs, and large is 13 inches and greater. And these are the sort of breakpoints that you do have to be concerned with as a developer, and I'll show you a quick demonstration in a little while to show you how these things work. But typically, if you'd notice at the bottom here, we're saying this is 640 effective pixels or less. So you're going to design something that's going to work well at that size, and then figure out what changes you need to make when it goes above that up to about 1,000, just over 1,000, and then greater than 1,000, you're into the large category. And generally speaking, if you can do a good job of making things work at those 3 breakpoints, then typically the application will look and work fairly well across the whole range of devices that are available. I'm not going to go into all the details on this slide. It'll be there for you to look at later. But these are just a set of the point is there are a set of general guidelines that when you're designing for small device classes, do this, don't do that, position things in this way, make sure you leave margins of this kind of size, and so on. These are just a sampling from quite a detailed kind of design guide that's available on the Windows Developer Center. Tons of information out there, and the point is that Microsoft have done a lot of work for you in suggesting how you can go about designing these user interfaces so that they are flexible and will run well on a whole range of devices. There is a wrench in the works, though, which is something called Continuum. So this is also something you have to be thinking about, although you might decide that, like most of the rest of the world, you might decide that Windows Phone isn't something you're particularly interested in, which a lot of people seem to have made that decision, including Microsoft, it would appear. But when is a phone not a phone? There's this thing called Continuum now, which is actually seriously cool, and it's just such a shame that the Windows Phone platform is so small these days, because essentially what it does is turn your cell phone into a desktop device. So essentially you connect the phone to a docking station, and now you've got a big screen and a keyboard and a mouse. So the one kind of spanner in the works, as I mentioned, or wrench in the works, is that a phone can be a member of the small category and the large category. So you do have to kind of bear that in mind if you're wanting to support those environments. A little bit about universal controls. The whole point of building these flexible UIs is that they should work well across all of the platforms that your app is going to target. And Microsoft has done a pretty good job of giving us a set of controls that do exactly that work well with touch, work well with pen and ink, work well with keyboard and mouse and game controllers if you happen to be on an Xbox or using a controller on a PC. and so on. And there are, the whole set of controls that you would expect to be there are pretty much there. There are third-party controls available. DevExpress, Component One, Syncfusion, and probably some others do have Windows Universal control sets available now. But I think, like WPF, I'm not sure that those particular products are gaining a lot of traction. I think most people are pretty much doing it with the low-level controls these days because it's XAML, and you can style them with XAML style sheets, just like you can with HTML and CSS. So I would say it's the normal situation to just use the basic set of controls and get the styles in place to do the customization and give you that really advanced look and feel. That is the reason that a lot of people go to the DevExpresses and the Component Ones and so on. There are also some universal styles that are provided. Out of the box, there is, of course, it always seems to be light and dark these days, doesn't it? Even with Windows itself and a lot of the Microsoft tools. And again, the UWP platform itself provides some built-in styles. There is a light theme and a dark theme. You can elect to use one or the other. You can allow the user to switch between them. And they are provided in source code format, so you can take them as a starting point and customize them as well if you want things to be somewhat different from the sort of typical defaults. A little bit about the anatomy of a typical UWP application. Applications typically are made up of what are called pages, and pages have UI that tend to be, this isn't a hard and fast rule, but most UWP applications have certain elements of navigation elements that help you navigate around the application, command elements where you're selecting, go make something happen, and then content elements that are presenting information to the user and allowing the user to interact with that information. All applications have at least two screens or two pages. They are the splash screen and then some kind of main start or home page where the application starts after the splash screen is displayed. But most applications have multiple pages that are navigated to and from as the application requires. So, very briefly, navigation elements help the user choose what to display, navigate around the different capabilities of the application. There are several types. There are tabs, pivots, hyperlinks, what are called navigation panes, lots of standard types of ways of navigating around within an application. Command elements, as I mentioned, initiate actions, so the typical command element is of course a button, but also lots of different kinds of ways of initiating commands, command bars, keyboard shortcuts, even if it's on a keyboard and mouse type scenario, and content elements, like I say, present things, fields, charts, images, that whole range of all the typical controls that you would expect in traditional Windows environments, and some more modern ones that are sort of specific to this environment. Why Tailor Apps for different screen classes? Really, it's almost impossible to write a single application and have it work well with a single UI definition across all of that wide range of screen sizes. So typically, you're going to be wanting to, if your app supports multiple classes, you might just say, I'm using the UWP to get a great touch experience, and all I'm targeting is desktop. Or maybe desktop and tablet, because they're a similar form factor, in which case you need one UI and you're good to go. But if you are trying to target different sizes or different size classes of application, then chances are you're going to need to do something to determine what happens when the app is run on a small device versus a medium or a large device. And there are various ways of approaching that. Also, some differences in, some devices might have sensors and cameras and so on that you want to take advantage of, and some may not. So there are different, you might need to take care of designing for different platforms and different capabilities. The best way to go about that is through something called responsive design. This is something that in WPF could be quite a challenge, but the UWP platform provides quite a few nice little tools that really make this quite a bit easier. Some new layout controls, for example, that help you really create responsive or adaptive UI. So the idea between a responsive or an adaptive UI is that this is a single application binary that will adapt its UI to its surroundings, essentially, depending on the type of platform that it's running on. And Microsoft talk about the 6 R's of responsive design. And these 6 R's are techniques that you can use as a UI designer to help you create that responsive or adaptive UI. So the 6 R's are, the first approach is to reposition something. And the example you can see on the screen here, A and B on the narrow platform are being placed above each other, but when the application goes above a certain width, those things have been repositioned to make better use of that space and present the UI in a different way. But it's done with a transformation, so it's not like you're providing a totally separate user interface. You're defining that if the width of the UI is less than this, then position that one above that one, otherwise put it next to it, kind of thing. And it's all designed into the single UI. The second R is to resize something. And the example there is, again, you can see on the screen, there's a block of text there that's being resized, and you can see they've got different sizes of margins as well, just to make it look appealing as the width. And remember, this is not cell phone versus tablet. This is all just based on the width of the application, regardless of the device type. Just because an application may run on a desktop PC, the user may still choose to resize it to be only this wide. So this totally applies if you're just developing a desktop application. This is not just about devices and tablets and phones and so on. The next R is to reflow something. Again, pretty much with text usually, but it could be with collections of images and grids and so on as well, to change the flow of how the UI is being presented from 1 column to 2 columns to 3 columns of something, whatever it is, as the width adapts. The fourth is to reveal something on a narrow, when something's in a narrow mode, hide some stuff away or make it look like it's flowing off the screen or something, and reveal more and more of whatever that is as the application width increases. Replace is the 5th R, and that is basically to say, okay, at this width I'm going to do this, and I'm going to, as the width increases or decreases, whatever, I'm going to replace it with something totally different or some different way of implementing whatever it is. And then the final R is to re-architect. And this is probably the one to avoid unless you really have to. And the idea there is I'll have a totally different UI for different devices or different widths. And literally developing multiple UIs, not having a UI that adapts and so on. Let's just, again, to help us understand some more about that, let's just watch another brief video.
The Universal Windows Platform provides the building blocks you need to create elegant and adaptive Windows apps that look great on a wide variety of devices. First, UWP automatically adjusts the size of the controls, fonts, and other UI elements so that they are legible on all devices. UWP uses a new effective pixel system to achieve this. UI elements are automatically optimized for perceived size, so that a 15-pixel font on a Surface Hub 10 feet away is just as legible as a 15-pixel font on a smartphone in your hand. With this, you can ignore details like pixel density and screen resolution, and focus on how you want the app to look. Second, UWP's Universal Input System automatically understands a variety of input from different devices. You don't have to worry about how your UI responds to the tap of a finger, a mouse click, or an air tap on a HoloLens. It just works. Third, UWP apps come with a set of universal controls and styles. Universal controls work well on any type of Windows device. They adapt to the different screen sizes and different input modes on each device. Our built-in universal styles come in 2 themes, light and dark. These styles use a Segoe-based font that looks crisp at all sizes, supports high contrast modes, and supports adapting your app to other languages. You can ship your app with these styles and it will look great. Or you can use these styles as a starting point and add your own personality to the look and feel. You might want to optimize the use of screen space, take advantage of specific sensors, or tailor the experience for a specific type of input. If this is the case, there are some techniques to help you design your app for a specific screen size. We call these techniques the 6 R's. Depending on whether a screen is portrait or landscape, you may want to reposition some content. It may be easier to scroll content vertically on one device and horizontally on another. If you have a larger screen, you may want to resize some elements and adjust margins and spacing. This may improve readability and comfort. There may also be times you want to reflow content by adding another column if the screen size allows it. Also dependent on the size of the screen is whether you reveal or hide some elements. In tighter spaces, you might want to hide controls until needed, whereas on a larger screen, they could always be visible. In some cases, you may want to replace or re-architect some UI. You may want to change how you dive deeper into data and take advantage of the layout of the screen. The Universal Windows Platform takes you a long way in creating apps that run great on all Windows-powered devices.
Okay. In terms of getting started, we all got a flavor of a little bit of design with Billy's presentation last year. Microsoft have actually done some work in the interim and provided some tools that help with design as well now. They basically provided little plugins that can be used in some of the most common environments that designers tend to use when creating wireframes and so on. So Adobe Illustrator, Adobe Photoshop, and PowerPoint all have little plugins that you can download. And they give you basically a palette of representations of all of the whole suite of UWP controls and windows and different types of devices and stuff like that. And you can drag them around and build representations of user interface to help you with that design process. So I've put the URL to those on there, but they're readily available through the Windows Developer Center. In terms of implementing page layouts, as I already mentioned, chances are most UWP apps are developed with XAML. Like I already said, it's not the exact same XAML as you would use with WPF, but it's very, very similar. There are some differences in the way that data binding should be done that are more efficient and so on, but it's a very similar experience. Like with WPF, typically developers would use the MVVM design pattern to implement, using views and view models and so on. It's not mandatory, code behind is still there and will still work, but most people like to follow those good practices with a structured approach. And I already mentioned data binding is similar in concept, but syntactically a little bit different. It uses something called XBind instead of the old binding that WPF uses. There is a graphical designer that can be used in Visual Studio as well, but right now, as of today, it is somewhat unstable. Even in the C# and VB environments, the graphical designer is pretty bad at this point in time. Implementing a responsive layout is something that typically is done, like I say, in XAML as well, and there are a couple of tools that make this really quite useful. If you've ever done WPF development, you're probably familiar with visual styles. And again, that's how adaptive UIs are built, with visual styles that are applied. And the one thing that UWP adds is something called the adaptive trigger. So the adaptive trigger is something that can help you trigger changes in visual state based on criteria within the application. And a very common example of that is the window width. So you can have an adaptive trigger, minimum or min window width is 700, and that trigger will fire as the width of the application crosses that point. So you can use that to trigger changes in the layout of things, the size of things, swap out one page for another, that kind of thing. So that's the mechanism for how you build those kind of responsive UIs, or the primary mechanism, it's not the only one. Let's talk very briefly about deploying UWP applications, because this is an area that has changed an awful lot since Windows 8 was first released. When Windows 8 was first released, it was basically, if you develop a store app, as its name suggested, you had to go through the Microsoft Store, period. Now there's a lot more ways of doing that. You can now put Windows 10 devices, Windows phones, tablets, whatever, into developer mode, and that lets you sideload applications during development and for testing. You can also do that in the phone emulator if you're wanting to use the emulator rather than a device. That runs as a Hyper-V virtual machine and runs very well. And like I say, putting the device or the emulator into developer mode lets you deploy your own applications there. UWP apps are deployed via something called an Apex package. It basically guarantees certain things and gives you and the user certain levels of security and so on. An Apex package is essentially just a zip file with a different file extension. So if you look inside the Apex package, there's all the binaries and the images and videos and whatever resources that application uses. That single file is what gets deployed to a system from the store or through other mechanisms like side loading. These Apex packages are created with tooling in Visual Studio. Right now they are installed through apart from side loading, they're installed through the store app. But again, in Windows Anniversary Edition, there's a new mechanism which will let you just double click on an Apex file to install the application as well. That's not there yet, but that's coming in the next version of Windows. In terms of deploying applications, the primary mechanism is still the Windows Store. There are mechanisms there for publishing public apps. The Windows Store has public access, clearly. There are mechanisms for having free apps or paid applications if you're willing to give Microsoft their 30% cut. The Windows Store does also support free trials, which is something that's not present in some of the other app stores. That's quite a nice feature. And there are now ways of doing organizational volume pricing and giving discounts if an organization buys X number of copies of the software and stuff like that. And also obviously support for doing things like in-app purchases, which is becoming a common model in a lot of apps these days. One of the biggest changes was that Microsoft now operate what they call the Windows Store for Business. So this is a way of a company having their own private portal within the store. So it is still the Microsoft Store online, but it's a private portal for an organization, and they determine what apps are available in that store. They can publish their own apps to the store. They can authorize other developers to put apps into their store, and there's the distribution mechanism to install those apps onto PCs within the organization. So that's something that's there. It's been there a little while now. And also there are mechanisms now to do administrative side loading, official mechanisms to do side loading of applications. If you really don't want to use the store, then there are mechanisms to allow you to do that. That used to require some rather expensive software licenses to let you do that in Windows 8. That's completely gone away now as well. There's no additional cost involved with side loading applications anymore. The apps do have to be signed in all cases though, so you will need a real code signing certificate from a recognized certification authority to be able to publish apps through any of those mechanisms. The Windows Store for Business, basically the process is, as an enterprise or a company or an organization, you establish with Microsoft a private store, and you then authorize your own or other third-party developers to submit applications to that store for you. Right now, the Store for Business is only free applications, so this is not a mechanism for paying for things. That is going to change. It will be supporting paid applications within Store for Business as well in the near future, but right now this is free applications. So the developers then package up those apps into an AppX package in Visual Studio and publish them to the enterprise store. Those apps still do go through Microsoft certification. So there are guidelines and there are things that you're not allowed to do. That list is an awful lot shorter than it used to be. You know, it used to be a pretty restricted sandbox for an old Windows 8 store app. It's not that case anymore, but there is still a certification process. And once approved, the enterprise's admin gets to then push that application out to the store and publish it to their users and determine who can download it and who can't and all that kind of stuff. A little bit of miscellaneous stuff, I'm almost done now. Just wanted to mention application lifecycle, because there are some differences here between traditional desktop apps and universal applications, in that there is this life cycle where an app can be in basically one of three states. In a not running state, clearly it's not running at all. In a running state, running implying that it's running and it's visual, it's on the desktop and the user is using it right now. And then there is this suspended state. And pretty much as soon as you minimize the application and the user is not using the application anymore, the app is probably going to go into a suspended state fairly quickly. And once it's in a suspended state, you do get to run some code when that happens. You don't get to run code for very long when that happens. There are some mechanisms in the next version of Windows coming to let you extend that time out a little bit more, but it's a matter of seconds pretty much right now. So the idea with UWP applications is you always need to be prepared to be closed at very short notice. So most UWP applications don't have the concept of save. They pretty much constantly are saving. Whenever anything changes, it gets saved. So you really want to develop the application so that it's pretty much in a state where it could be closed at as many, all the time if you can. So you don't allow unsaved data to be around. That's something you certainly need to be aware of. And like I say, there are some changes, a lot more flexibility to that whole mechanism, and a lot of new stuff that makes it possible to run stuff in the background, even when the app is closed in the new anniversary edition in the summer. There is another interesting thing as well, which is called Project Centennial. And Centennial is basically now the ability to take an existing desktop application, a Win32 application or a .NET application, and package it up as a UWP application. Okay, and the primary reason here is the fact that there's now the Store for Business, which is actually quite a nice way of maintaining your portfolio of software that your employees in your company are going to use, and what gets installed on a new PC, and how does that happen when a new PC enters the business. So there is this mechanism to package up Win32 and .NET applications inside a UWP application and then publish them to your store for business, basically, which is quite a nice capability. The way it works is there's an app converter that basically watches, it actually executes the installation for your existing product. So it runs the MSI and sort of watches what it does, and it records every change to the registry, every file that gets provided, every change to the system environment, and so on. And then it builds all of those actions up into an AppX that does basically the same thing. So it's a fairly easy process most of the time. I've not actually done it. This is all based on just information that we were given at the Build conference recently. Also, if you're creating your own installers, FireGiant, who are the company that deal with the Wix installation environment, I'll be talking about that later in the conference, but they also have the ability to create AppX packages based on Wix installations. So if you do have an application that you want to deploy both as an MSI or an AppX for some reason, then there are some tools that let you do that sort of dual packaging based on a single definition of the installation these days. Also briefly, Xamarin Forms. I don't know whether you know, I'm assuming most of you know Xamarin is the tool that lets you do .NET development for iOS and Android, amongst other platforms. It's the tool that lets you develop a single app that works on iOS, Android, Windows Phone, and so on. Xamarin Forms has had support for UWP since Xamarin Forms 2.1. So in theory, that means that you can, and again, this is not something I've done, but that would mean that it is possible to create a single application that works across all of the UWP devices and iOS and Android as well, which is kind of an interesting concept. There's also something called the Windows Bridge for iOS. This is just background information at this point. I'm not sure if this is of interest to people in the room. It's just really background. But the Windows Bridge for iOS basically opens up the UWP environment and in particular the store to iOS developers. So Microsoft have now put a bunch of tooling into Visual Studio that lets it basically open and consume Xcode projects. And it's got full support for Objective-C in Visual Studio and all of that tooling. So basically the idea is that someone who's got an existing iOS application for an iPhone or an iPad or whatever can take that code, run it through this tooling in Visual Studio, create an AppX package for it, and deploy that iOS application to the Microsoft Store and install it on Windows devices, which is, again, quite an interesting concept. Very briefly, I wasn't going to demonstrate this in any great length, but I just wanted to show you an example of a very simple Windows app. Really just to point out that there are several examples out there. This is one of Microsoft's example applications. It's kind of faked out. It's a social networking, photo sharing kind of thing. And really, I just wanted to show you this example. I'm not going to go through and demonstrate the application itself. I was just going to use it as an example of the adaptive UI. So here, as I've opened the UWP application, you can see, or even if I go full screen with it, you can see that the UI is set out a certain way that works pretty well on a fairly large scale monitor. This is like a 28-inch monitor or something up here. But you can see what happens when the width of the application decreases, and there's several breakpoints that they've supported here. There's the first one. Did you see it? So it got just below a certain width, and all of a sudden the images go a little bit smaller, just to let you still see quite a good amount of content. But there's an example of adaptive UI. So the developer's taken the decision that once we get below whatever that width is, we're just going to scoot those images down a little bit so that you still see quite a few of them. And as we continue to go in, it happened again there. Okay, they got a little bit smaller. We're actually seeing one more row because of that now. As we go in a little bit further, we're now getting towards sort of typical tablet kind of sizes, probably from landscape to portrait. There's another breakpoint. You see at the top here we've got two areas of content, and this one's cycling around, and we get below that point. Oops. We get below that point, and now we've only got one area of content at the top there. And then there's one final breakpoint, I believe. If you notice, oh, there's two actually. Oh no, maybe one. You notice right now we've got our menu available up here, and it's taking up that amount of width, which is acceptable at this kind of width. But we get below towards a certain point and we'll say, okay, we're not going to waste that UI space anymore. So let's scooch that menu down. It's still available. We just don't see the bar down the side with the quick access to each icon. We have to go via the hamburger menu now. So that's just an example of adaptive UI. I think that's it. It pretty much bottoms out there. But if you think about what that looks like, let's just see what that actually looks like compared to, let's take the exact same executable and let's run it over here. So this is just a little viewer. So I've actually got a Windows Phone device here, and if I turn it on, you can see the screen there. And basically there's our Snap Gold. This is literally the exact same binary application that's running on Windows there, because this is a Windows 10 device, and there's the application running. And obviously at this width, we've gone straight into the same user experience, oh sorry, that's that way, that we're seeing here. This is really kind of the same thing, although I'm not sure why I'm not getting the content there. Not getting the images for some reason. It was earlier, don't know what's going on there. But you can see, you know, the UI organization that the Windows app went into as we got down to that lower width is basically the default behavior on the phone device. Not sure why the images aren't working on there. I must have screwed something up. As an example of that adaptive UI that I was talking about. Okay, I think we're about there. Recommended reading. I've tried to pick out a few recommended books for you for each of my sessions. So very, very useful. I found this one, Rewriting Your UI Every 6 Weeks. Yeah, absolutely top reading. Can't recommend it highly enough. And of course, using these latest and greatest tools is great for the resume as well. So resume-driven development. I highly recommend the book. Okay. But seriously, there are lots and lots of resources out there online. If you are interested in finding out a little bit more about UWP, the place to go is just the Microsoft Developer Center. So developer.microsoft.com, hit the Windows button, and you'll get into a whole bunch of information about UWP and sample apps and code and all kinds of other resources out there.
Thank you.
All right, thank you.